Going to continue now with Eclipse. You notice that I have switched computers to a Mac, but we are at the same place as we left off in the previous video. We've created the arrival process, its extended SimEntity base, and we've created the Javadoc. We have also, if you remember, loaded Simkit as the user library, and we are now about to implement the arrival process. If you remember, the arrival process has a parameter, which is the time between the arrival events. It also has an integer state variable that will count the number of events. The two events are run, which is the one special event which initializes things and is always put on the event list at the beginning, and the second is arrival, which is a user created one. We'll begin with the parameter. Now, a very useful class in Simkit is called random variate, and that can be used to generate random variates of a variety of distributions, including ones that have a fixed or constant value, or ones that have a particular set sequence of things. However, for this we are going to use the exponential distribution when we wind up implementing it. However, the component doesn't know or care about that. So a random variate can be any distribution that we want. We can decide when we actually create the thing. Now, parameters are declared to be private instance variables with setters and getters. So we will first define the instance variable private random variate, case sensitive here, and we will call it integer arrival time generator, because that's what it will be doing. Now you see the red squigglies on random variate, and if we hover on it, we get a choice, and we can import the random variate, or, well, that's exactly what we want to do, and we see that sends the red squigglies away. The other thing we can do is we can generate the getter and setter. And one way that NetBeans provides to do that is if we just click on the variable, we can select create getter and setter for enter arrival time. Let's generate the method comments, and we OK that, and we see that the setter and the getter have not only been created, but they've created with the misspelling of enter arrival time generator. So let's generator. Now, one of the nice things about the ability to do this is that it makes it fairly straightforward to pick up mistakes like that and correct them. So we will create the getter and setter again by clicking on it, and we see that that's now spelled correctly. This process will be repeated for every parameter that you will have in your component. In this case, we only have one, so we move to the state variables. A state variable is protected, and in this case, it's an integer, and we will call it number arrivals. Again, we can hover, and it doesn't seem to give us that option of press F2 for try that. Okay, so what we can do is right-click, select source, and generate getters and setters. Same deal as before. So here we have get number of arrivals. Because it's a state variable, we only want a getter. We do not want a setter, so we uncheck that. Let's generate the method comments, and we see that we have the getter has been generated for us. This process would be repeated for all state variables. In this case, we're done because we only have one. We're now going to create two constructors. The first is an empty parameter constructor. We will not be using that at first, but that's something that can be handy later on. So there's our empty constructor. That should be used with caution for reasons that may be obvious. Now our second constructor will have as its signature a random variate that will be passed to our parameter. Okay, so in general, for every parameter we have, the second constructor will have an item in the signature for that parameter, and what it will do, what the constructor will do, is simply set that value. So that's what we should be doing. That's all we need to do here. Now we need to implement the events. The first is the run event. The run event is very special in that its state transition is the initial, setting the initial values of the state variables, and that is implemented using two methods. Eventually, why it's done that way will be understood. For now, we'll just press the I believe button. And the two methods are reset and do run. And for reset, you should always call the super as the first line. And you set the number of arrivals to 0. Okay, where did I get that from? From the definition of the event graph. Now the other method for implementing run is the method do run. So it's public void do run. And all other methods besides run are implemented using just the do method. So we have one other event, it's called do arrival. So the method is called do arrival. Now let's return to do run. It's going to have two responsibilities here. One is to fire a property change for the state variable, and the second is to schedule any initial events if necessary. So in this case, we do want to do both, so we will fire the property change for number of arrivals, and get number arrivals. Second thing it's going to do is schedule the arrival event. We do that using a call to wait delay. Now the first item in the call is a string, which is the name of the event. There's no do in it, just the name of the event. And then the second argument for the two-signature version is it can be either a double, which for a constant amount. Oftentimes we use 0. In this case, we will use the inter-arrival time generator, so you can pass a random variate as the second argument, and it will simply generate the next one. Now for the arrival event, we need to do the state transition. The first state transition is that we set the number of arrivals to 1 plus whatever it was. And then we are going to fire a property change in exactly the same way we had done previously. So in general, whenever there's a state transition, there are going to be two things we do. One is to perform whatever the state transition is, and then the second is to fire the property change associated with that. Finally, we have a scheduling edge from arrival to itself. So we will schedule an arrival, and the time is an inter-arrival time generator. So that is our completed arrival process component. Well, almost completed. Let's see, somehow this getter managed to get up here. So let's move that down to the bottom. Just because well, you can arrange yours however you like. I like to do the parameters, then the state variables, then constructors, then the do methods, and then finally the setters and getters for parameters, and then finish up with the state variables. That's just my preference. You can do whatever you want in that, as long as it makes sense. Just don't randomly mix stuff up. Now the question is, does this work? So what we are going to do is create a new package to hold our main methods here, and I'm going to call it run. So under the name is going to be OE3302.run, and we see here is the package that gets created there. So we're going to put our main methods there, our run methods. So we're going to create a new class. We're going to call it run arrival process. And now our superclass is just going to be object, because we don't need anything else there. But we are going to need a main method. So we click on main there, we finish, and there is our execution class. Now the first thing we need to do in creating an arrival process is to get the random variate. So let's see how that goes. A random variate is actually an interface, for those of you who care about those things. The important thing is, apart from the way it's spelled, okay, so let's start by defining our variable into arrival time. So we get a red squiggly here, and we will choose an import. Next, we will get the value. So here's how you do that. It's a static call to random variate factory. Variate. And the call is get factory, get instance. Now, we have a lot of choices we can give here. So what I'm going to do for this is to choose the exponential distribution. I give that as a string. It is case sensitive. There must be a capital E and then a list of the parameters. The exponential distribution can be parameterized by either a mean or by a rate. Simulators tend to like the mean, so that's what it means here. If you're using another platform and you come across an exponential random variate, chances are it's the mean, but make sure you check it out, because it could produce bad results for you. Okay, so now this is what we're going to put in our arrival process. And let's do this all in one line. So we have a new arrival process. Oops. And let's use this one. I didn't want to use that one. I wanted to use, so we wanted to import the one that we are using here. So make sure you're importing that arrival process. Now the first thing we want to do is make sure that our arrival process has in fact received the parameters that we thought it had gotten. The way to do that is to just do a print line on the object. The way Simkit is organized, it will list whatever parameters it has. So we will run this as a Java application, and what I'm hoping to see here is that indeed it has gotten the inter-arrival time generator as exponential. Now to run it, first we need to set up the event list. The event list is in a class called schedule, and there are static calls to schedule that we can make to set it up. So one is called verbose. So if we set verbose to true, then what it will do is it will dump the event list after every if schedule event. The second thing we need to do is to tell it to stop. For the arrival process, it's just going to keep going and going, and unless we stop it in some other way. So this is how we are going to stop it. We're going to say schedule stop at time. And let's stop it at time 10. Now we're ready to actually do the run. That requires two calls. The first is a call to reset, and the second a call to start simulation. So reset is basically like a giant reset button, and it takes every sim entity base and invokes its reset method so that its state variables, the state variables for every component begin in their initialized value. And then start simulation just kicks off the event list. So let's see what happens here. And we see that we began the simulation with two events, the run, that's from the arrival process, and a stop event at time 10. That's what happened when we told it to stop them. And then we see that we run the event list algorithm. So it simply pulls the run event off, run had scheduled arrival, that arrival scheduled another arrival, etc. until we hit the stop event, and then that canceled everything. Now the other thing we need to check is the state transitions. In other words, are the state transitions correctly being executed? We do that by listening for those property change events. And one very handy little class for doing that is called a simple property dumper. And okay, so we create one, and then the way we make it work is we add it as a property change listener. So we add property change listener to the arrival process. So every time that fire property change gets called, the simple property dumper will hear that, and you'll see what it does. So here's the same run, but with the simple property dumper going, and you see that when the run event occurs, that the number of arrivals was set to 0. When the arrival event occurred, it went to 1, 1 plus 0, and then 1 plus 1 is 2, last I checked, and then 3 and 4, etc., until we're done. So we can verify that our state transitions have been correctly implemented, and now we've at least had some basic functional testing of our component. Now the one thing that it's missing is the commenting. Make sure that there are Javadoc comments on all the methods that make a difference. In this case, the reset, do run, and do arrival all need comments.